my fellow assassins, to another episode of the Dark Assassins Podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. So I am going to just skip right over this week's episode and let you guys in on next week's episode. And so I've been doing a little chef work, I guess you could say, behind the scenes, and I've been cooking up a good one, which I'm hoping should be out next week. And needless to say, you'll know it when you see it. I'll just put it like that. So I am very excited for what I hope to be next week's episode. So you're definitely going to want to tune in next week, especially. But enough about next week. Let's get into this week's episode and start off with our trivia question. So for this week's trivia question, what was the first computer virus to appear in the wild? And bonus points if you can also guess the year and the operating system. So what was the first computer virus to appear in the wild? Now, this is a really interesting one because there have, as we'll get into at the end when we reveal the answer, there were numerous viruses that existed before this one in particular, but those were generally always in a contained or lab environment specifically for like research purposes. So there's a chance that you might be thinking of one that actually was potentially one of those scenarios. But also, speaking of viruses, that is a great segue into this week's cybersecurity tip. So for this week's cybersecurity tip, as I alluded to on the topic of viruses, don't take antivirus software as gospel. Don't trust your antivirus, because just like any other piece of security tool or any other kind of security, it's like Swiss cheese. It has holes in it. It ain't perfect. And in some cases, it is far from perfect. Now, depending on the antivirus you use and depending on how it's programmed and designed, it generally works on one of two or sometimes both methodologies. The first one being a signature-based antivirus model. Now, these are, quite honestly, pretty darn stupid because you can easily fudge the signature of your software, and specifically as a software developer, I could easily program a piece of malware that has never been seen before, is in no database whatsoever, and it'll slide right on through any signature-based antivirus. So they're not very smart. Now, they are pretty darn good at detecting viruses that already exist. So like known instances of worms, Trojans, ransomware, rootkits, keyloggers, all that kind of stuff, all the bad stuff you definitely don't want on your system. If it's a really common, widely known, widespread virus out there, there's a good chance that the database that this antivirus is going to be matching signatures against, there's a good chance that that piece of malware is going to be in that database. But the other kind of malware is heuristic-based antivirus, or I guess the other kind of antivirus, rather, is heuristic-based antivirus. Now, heuristic-based antivirus works on the power of AI and machine learning to detect different patterns commonly associated with malware. Now, one way that you can generally easily detect, although I guess part of it too would be signature based, but one way to detect if your antivirus could potentially be using heuristics, is try to install a crypto miner onto your computer, because antivirus hates crypto miners. Anyone that's tried to mine cryptocurrency themselves is probably well aware of this, especially if you're on Windows, because Windows Defender, it really hates it really hates crypto miners. Another thing that Windows Defender also hates is there are certain tools out there that you can use to like what's the word that I want to use here? Auto activate your, say, Office license without actually paying for one. And Windows Defender also does not like those scripts either. Now, how much of that is actually heuristic-based antivirus because it actually thinks it's a virus versus Microsoft just baking that in because they don't want you getting in a legal version of their software, I guess, without paying for it. So I'll leave that one up to you to decide, but that is one thing to point out. Although I will say, as far as antivirus hating on crypto miners, that is not entirely true, because there is one piece of antivirus in particular, looking at you, Norton 360, which does not hate all crypto miners. Well, it does hate all crypto miners, of course, unless you are using the crypto miner that it bakes into its antivirus software. Yes, you heard me correctly. Norton 360 bakes a crypto miner into its antivirus software. So, how the turntables. Which, by the way, their crypto miner is quite literally atrocious. It is by far more malware than any other crypto miner out there, largely because they take a whopping 15% commission on all of your earnings that you make using their crypto miner, which is quite terrible. And to put into context for you, generally, if you download a crypto miner to mine cryptocurrency, the default commission is 1%, and that goes to the developer of the miner just so they can, get some money for their troubles, for their effort of making this crypto miner. But in some cases, you can even go into the settings of the crypto miner and set that to 0. But not so with Norton 360. So that is kind of funny. But so when you're talking about antivirus, another thing that you have to watch out for if you are using antivirus is you want to check your settings also, because there's a way that these heuristic-based models and these signature-based models add to their intelligence. In the case of heuristics, add data to improve their heuristics, or in the case of signature-based models, add new signatures to their databases. Now, if you're not picking up what I'm laying down here, they collect data about the various files on your system and will send that off to whoever their creator is in order to, in their words, quote-unquote, improve their antivirus. Now, how much of that is improving the antivirus versus just spying on you? You gotta weigh the pros and the cons about, how much you value your privacy and security. You gotta weigh those, as we mentioned in previous episodes. Privacy versus security, sometimes it's kind of a one or the other type of a thing. It's not, you can't really have your cake and eat it too. But the other thing with antivirus that I personally noticed is it is one heck of a resource hog. I can't tell you how many times, specifically on Windows, that I'll be using some kind of antivirus and I'll notice my system is just chugging and chugging and being so darn slow, and then I'll bring up the task manager and see that the antivirus is using like 100% of my CPU for no apparent reason, doing whatever it's scanning or whatever behind the scenes. So sometimes, in an ironic twist, antivirus can sometimes almost act like malware, which is ironic because the point of having antivirus is to keep your system protected from malware. So a little bit of irony there. But as much as I'm kind of hating on antivirus here, I do think it can be a valuable tool to have as one of your layers of Swiss cheese. We've talked about the Swiss cheese model the past couple episodes, and antivirus is just another layer of Swiss cheese. Just like a firewall is, just like making sure your ports are closed, just like making sure you have strong passwords and two-factor authentication. It's just another layer of Swiss cheese. Yeah, there's plenty of holes in antivirus, but dang it, it does a pretty good job at blocking viruses and malware in most cases. Sometimes too good of a job because you're trying to download and use something that you know is legit, but the antivirus does not think so, and then you're stuck fighting with it for sometimes hours on end just trying to get your application to work. If you can't tell, I'm speaking from a little bit of experience there. Now, another reason why antivirus could definitely be a good tool for some people is not everyone is the most technology savvy when it comes to downloading software from sites. Because while some people, specifically the younger generation, although not everyone in the younger generation, knows that if you see the big green download button that's flashing and, blinking and all that stuff, generally that's not the button you want to click on. Generally, if you're going to sites that have those kinds of buttons, you're generally on some pretty sketchy sites, so you probably shouldn't be downloading anything from there anyway. But some people aren't necessarily as in tuned to this is, designed to scam me and be malicious. Generally, the people that I'm thinking of are generally the older folks, although in fairness, I do know some older folks that are definitely more tech savvy and tech literate than some younger people, and also like kids and, whatnot. So it can definitely be a good tool to have in your toolbox. If you have like a computer that's used by multiple people, it could be a potentially a good tool to have there. Another place where you'll almost always see it is on any kind of corporate system, corporate network, partly because, as the reason we just mentioned, some of the times those machines are shared amongst various users, so not everyone might have the same knowledge that I shouldn't be going to this sketchy site and hitting the big green download button and running the executable. But also, generally, corporations are more of a target for different types of cyber attacks, like phishing attacks or ransomware attacks or that kind of a thing. So having some kind of antivirus on there, on the networked computers, to be able to stop that as soon as possible is, can be a benefit there as well. So it's definitely a tool that you should potentially consider depending on who you are and your use case. But if it's just you and you have a very good level of common sense and aren't going to sketchy websites and downloading very sketchy things, you probably don't need it. But then again, especially if you're on Windows, Windows Defender, in my opinion, is more than adequate. And then if you're on Linux or Mac OS, I guess the mantra is malware doesn't exist on those machines, which is not true. But generally speaking, you are more safe solely because there are less of you out there, not because macOS or Linux is inherently better at security, but because the amount of potential targets is just smaller, so it makes you a less valuable target. But it's definitely something that you should consider when it comes to should you or should you not have antivirus. But regardless of if you decide to use antivirus or not, you definitely should not take it as gospel because it can get stuff wrong. So that is your cybersecurity tip for the week. Now, just kind of in general on the topic of viruses and stuff, one thing that is kind of fun to do is to write your own malware if you're a software developer. Obviously, you don't deploy it anywhere, but, writing the fork bomb if you're on Linux, that's a common one, just to harmless things that'll just like totally crash your system. I remember I wrote one back in, I think it was probably high school, and basically what I did was I wrote a program. I forget what it did. I think what it did was it just continuously opened up a bunch of different like windows, which is essentially what the fork bomb does. Just opening up processes and those processes open up more processes, and those processes open up even more processes, and it's this recursive process of all of your processes are opening up more processes, and then you just flood the CPU and everything just grinds to a halt and your system crashes. And from what I recall, I wrote like a batch script, I think, and created a shortcut for it and changed the icon to like I think the Google Chrome icon or something, and called it Google Chrome. So then like if you clicked on it, it would just like totally crash the computer. Obviously, don't go around writing something like that and putting it on anyone's computer unless you have their permission to. And obviously, you should only be using it for, one, educational purposes, and two, for fun. But you definitely don't want to be letting that out into, onto, say, your friend's computer or on your work computer or on a school computer or anywhere else you don't have permission to. So just one thing to be careful of, but it is fun to play around with and write your own malware. So with that out of the way, let's get into what nerdy stuff have I been up to this week. So this week was a little bit more of a lighter week in regards to nerdy things, but one thing that I did do was I had been noticing, I've been talking the past couple episodes about power draw of my home lab, aka data center. And I set out to try and figure out why my Tesla P4 card was constantly running at like 24 and 25 watts, even though it wasn't doing anything. And I finally figured it out. Now, originally, I thought the R620, the NVIDIA SMI command line tool, was just gaslighting me and I was hallucinating, because I could have sworn when I first installed that card and installed the NVIDIA drivers, it was idling at like 7 or 8 watts, and then, did some updates, rebooted everything, and then it was just running at 24, 25 watts, and I was like, wait, am I imagining things? Did it always do this, or what's going on here? So I kind of got to the point where I just figured I was going crazy, but turns out I was not going crazy. For whatever reason, the NVIDIA drivers only seemed to actually apply themselves when the card was in use. So if I wasn't actively doing something on the card, like I wasn't actively running a program that's using the GPU, like a CUDA program, running some GPU algorithms or, computations on a GPU, or if I was running Stable Diffusion, then the driver would be active, but otherwise it wouldn't. And when the driver isn't active, the operating system kind of has to figure out what to do on its own, so it just kind of uses a default driver to deal with the card, which obviously isn't as optimized as the legit driver. So that's kind of my theory. The other thing that I did notice was the P state, or like the sleep state of the card, was always at P0, or essentially non-existent. It was just always active, which if you're trying to go for power efficiency, that's obviously not what you want to do. Now, I figured out that you can actually manually turn on the persistence mode to make it always on, which maybe I was not reading the documentation right, but I could have sworn I saw on the documentation for turning on the persistence mode that it said the driver will always be active and it'll make the responsiveness a lot faster, but it'll also draw more power. Which, that last part, potentially I read it wrong, but that's the complete opposite of my experience. It drew significantly less power than it not being enabled. And the reason why is because when I have it in persistence mode, it's able to go into P8 stage, which is like, I guess, I'm assuming the lowest level of like sleep that it can go into is my assumption. So now it's back down to running where it should be, which is like 7 to 9 watts or so, which in the grand scheme of things, I'm pretty sure I did the math, and it came out to like saving me, I think maybe $2 a month. So not really much at all. But on the bright side, it is running like at least 10 or more degrees Celsius cooler now that it's using this less power, which makes me sleep a lot better at night, knowing my GPU is not slowly cooking itself inside of my R620, which is also very beneficial because as we start to get into the warmer months, and as I've mentioned, my upstairs where my server rack lives kind of turns into an oven. Definitely don't want things to run hot, because if things run hot, that means the fans blow, which means blowing more hot air into the room, which means the room heats up, which means the fans have to blow more to keep the things cool, which it's a, kind of a self-fulfilling prophecy there. Now, on the subject of cooling, I did kind of sort of figure out a semi-decent solution. Now, this is obviously far from ideal, and someone might be thinking that, I could just have a smart home that has a dedicated thermostat up in my server room to keep that at a certain, cool temperature. Couple things. One, I ain't into all that smart home stuff. The only way I'll ever get into the smart home stuff is if I can control everything myself. Nothing reaches out to the cloud. Everything's segmented off so it doesn't have access to the internet, and everything is controlled and localized within my house, and nothing ever leaves. Which, if you know anything about the smart home industry, there's a good amount of stuff that does not do that, and they reach out to the cloud, which I am not about. Now, the other thing is, the house that I am in is kind of sort of old, and it just has a dumb thermostat, which I kind of like because, I don't like the smart home stuff, because when you get into, being a software developer and someone that actually cares about cybersecurity and is interested in that kind of field, you don't like those, generally speaking, you don't like that kind of stuff because you know how it works and it spooks you. Now, a little bit of a tangent here. I'm sure some of you have seen the meme, but there's a meme out there where it's like the tech enthusiast is like, I have smart home everything, I can control everything from my phone in just one click. And then you have like the software developer, which is like, I'm scared of technology and I only use it because I have to. And then there's like the cybersecurity professional that's like, I only have, locks and keys, and my most recent piece of technology is a printer from like 2003, and whenever it makes a noise, I unplug it or something like that. Point being, the people that actually know how it works generally don't want to use it because they know how it works. But I guess it also can go the other way too, because if you're a locksmith and you know how easy it is to pick all the locks, like, on homes or whatever, you probably wouldn't want locks because you know how easy they are to beat. So you might opt for some kind of smart lock or something. Whereas from the software developer and cybersecurity aspect, you know how easy it is for those things to be hacked, so you don't want them and you want real locks. So there's two sides to it. Now, let's see, where was I? Oh yes, air conditioning. So my thermostat is able to be detached from like the unit it's in. So what I found is what I can do is I can detach it from the wall mount, bring it upstairs, let it bake in the oven, which is my upstairs, for a little while, bring it back downstairs, plug it back into the wall, and then the air conditioner will kick on because it thinks it's a lot hotter than it actually is. So then what I do is I make sure all the vents are closed on the downstairs and force all the air upstairs, so it basically only cools the upstairs. And what I found is I ran into some situations this week where my upstairs was actually cooler, and sometimes by a noticeable amount, than my downstairs, which never happens. So that was a pretty big win. The only downside is it'll then heat up the upstairs rather quickly once the AC shuts off. So it's kind of ironic and kind of sad and funny that when it's hotter outside, my upstairs is actually cooler, because that means the AC will be on more naturally, so it can actually keep the upstairs cool. Whereas if it's, generally a nice day outside, say it's somewhere in the mid 60s or even the low 70s, and it like warms the house up enough, a decent amount, but not like enough to turn the AC on, it actually makes the upstairs worse because the AC just never gets turned on. So it's kind of funny in that way, where it's almost better if it's hotter outside, because then the AC will just run longer and essentially never shut itself off, and therefore will keep my house cooler, which on the downside, because the AC never shuts itself off, that's just the money printer going burr out of my bank account. But the trade-off of having it actually livable upstairs is nice, because anyone that has had to try to sleep in hot conditions, say maybe your bedroom is over the garage in the summertime, that it's generally not that pleasant of an experience. So I think I will definitely be employing this hack throughout these months where the weather can't decide if it wants to be springtime or if it wants to be the middle of summer. So that is what I was up to this week. Now let's get into some good stuff, I think. So this one is obviously going out to all the software devs out there, and this is specifically about some software development tools that you should have in your toolbox as a software developer. Now, In some of these cases, I'm going to go into some like specific tools that you could use. Obviously, it's not going to be an all-inclusive list because, for example, one of the items is some kind of text editor or IDE. If I went through every single text editor and IDE out there, this episode would probably be hours, if not days long, and we're not going to do that. So we're just going to kind of go over some general principles, general tools, and then maybe go into a couple specifics just to kind of give you an idea of what tools we're talking about. So the first one, which probably should be obvious, is you need to have a compiler, or sometimes more than one compiler, or depending on what language you're using, an interpreter. So if you're using Python, you obviously need the Python interpreter installed, because if you don't, then you can't run Python if you don't have the interpreter. Similarly, if you're using another programming language that's compiled, like you're using Java, Rust, Go, C, C++, any of those, you need a compiler to actually compile your code into an executable so you can then run it. Because you can write all the code in the world, but if you don't have a way to either compile it or run it through the interpreter, it's basically useless. So that's obviously the first thing you need is the language's compiler. Generally pretty easy to install these. It's not too difficult. And the reason why I mentioned sometimes having more than one is if you're planning on developing for multiple architectures, specifically, generally it's not a problem, obviously, if you're using Java, and not a problem if you're using Python, but if you're using, a compiled language that compiles down to machine code, like C, C++, for example, if you want to develop, say, on Linux, and you want to develop for both ARM and x86 architectures, you have two options. You can have an ARM-based system and an x86-based system and compile your code on both of them. Or what you can do is you can download a separate compiler on your main development machine and then compile it for both systems using the different compilers just on your one machine. So that could potentially be an option for you if you're planning on developing for multiple architectures. So that would be a potential reason why you would want multiple compilers. Another thing that you could potentially want multiple compilers for is if you're developing specifically for some kind of, like if you're developing for a microcontroller or some other type of external hardware that you can't compile the code on. So if you're trying to say, if you want to use like a Pi Zero or something or some other microcontroller that you can't physically compile the code on itself, you have to, in those cases, you have to load the executable onto the device. So you need a way to compile into the machine code for that device, in which case you would need a different compiler than your standard one for your regular machine. Another good example of this is I talked about months and months ago, haven't really touched it since, but working on like Game Boy Advance programming. In that sense, obviously, I can't compile and run code on a Game Boy Advance. At least I don't believe I can. And trying to code on one of those would be an absolute nightmare, seeing that there's no keyboard. But anyway, since you can't compile code on that, you have to have a separate compiler on your main machine in order to compile into the binary needed that you can then load onto a cartridge to then run on the Game Boy. Or if you're using an emulator, you'd still need to, compile to the appropriate binary file in order to run it in the emulator. So those are reasons why you would potentially want more than just a single compiler. Obviously, if you're planning on using multiple programming languages, you obviously need more than one compiler too. But specifically, this was kind of more targeted to multiple compilers for the same language. Now, I mentioned this before already, but another tool that you should have in your toolbox is some kind of text editor or IDE, or integrated development environment. Now, there are some strong opinions, I'll say, when it comes to the text editors out there. Some people are hardcore Vim all the way, or NeoVim, and anything else is hot garbage. Then you have, the Visual Studio Windows folks that are diehard Visual Studio. There are some strong opinions when it comes to text editors and IDEs. So I'm not going to necessarily get into which is the best. That's maybe a topic for another podcast episode, but some of the big ones that I've used are Notepad++, Sublime, Vim, Emacs, VS Code, VS Codium, Xcode, Visual Studio, Eclipse, NetBeans. There's obviously a lot of them out there. Now, the reason why you want, some kind of text editor or IDE is because the nice thing about these is, I guess in general, you want something that has some kind of syntax highlighting at the very least. You don't necessarily need any kind of auto-completion. While auto-completion is nice, at the very least, you want some kind of syntax highlighting, because if you've ever, say, used Notepad on Windows to try to write code, it is one of the worst experiences you'll have in your life writing code for a couple reasons. One, there's no syntax highlighting, so everything looks the same. And two, it has no concept of what code is, so it doesn't do any kind of auto formatting for you or auto indenting, which generally you can configure these text editors, and specifically the IDEs will do it for you, which is very handy to have. And when you get more into the IDEs, the integrated development environments, with things like Eclipse or NetBeans or Visual Studio Code or Xcode, or not Visual Studio Code, but Visual Studio, the full fat Visual Studio, or Xcode, or one of the big IDEs, is generally they have really good support for auto-completion stuff. So if you've never coded in your life before, basically what this is if you start typing the name of, say, a variable, it'll give you some suggestions to autocomplete that variable. And then if that variable is, say, a class and it has different functions that it can call, as you start typing the name of the function, it'll kind of narrow down, and that you can select from there to autocomplete. So reduce the amount of typing that you have. Sometimes the autocomplete functions are better than others. But it is generally kind of nice to have, especially if you have a general idea of what the function is called, but you don't necessarily know it off the top of your head. So you can kind of start typing it and then, oh yeah, it's that one. And then you can just kind of hit enter and go on your way and keep coding. So those are generally nice to have. And the reason why the syntax highlighting is so nice is because it really helps you identify easily what's a function, what's, say, a class object, what's a variable type. It really helps you kind of identify what things are. You can easily look through and see what the comments are. You can easily see what the strings are. It really helps you visualize the code a lot better and just makes it look nicer. Plus pretty colors. Now, I think arguably the most important feature, hands down, that a text editor or IDE has to have to be worth its salt is a dark mode. Because everyone that's ever programmed knows if you're using light mode, you're an absolute psychopath. Because dark mode is the only way to code. That's obviously sarcasm, but dark mode is a feature that I and a lot of other software developers greatly appreciate, because when you're staring at a screen for hours and hours on end, the bright white light can definitely put a strain on your eyes, especially if it's a late night coding session and everything around you is dark except for your computer screen. Having that one singular super bright light coming off your screen from the white background of your IDE or text editor, not the move. But those are text editors, and that's probably a pretty good transition to the next tool you should have, which is some kind of debugger. Now, I know some of you out there, myself included, like to use the good old-fashioned, the old faithful, good old reliable print statement, but ideally you should use some actual debugger. Now, if you're using an integrated development environment, generally they have a debugger built into them. So if thinking like Visual Studio, Xcode, Eclipse, generally they'll have some kind of debugger built into the IDE that you can use to debug your code, which I've used them before. They're generally pretty good and pretty helpful. Other kinds of debuggers is GDB is a really common command line based debugger. I've used that also before in the past. But generally, if you're having issues with your code, debuggers, we've talked about this before in the past, but debuggers are a good tool to have because, for one, you can put breakpoints in your code rather than print statements. So then when you want to be done debugging, your code's clean. You don't have to go hunting through all of your, different source files and removing all the print statements, because I have ran into the instance where I'll think everything is all cleaned up and ready to go, and then I'll be doing some testing in my code and be like, why the heck is this random print statement here that essentially means nothing? What the heck is this doing here? And I'll be like, oh yeah, when I was debugging this thing like X hours ago or X days ago, I put this print statement in there to see where I was in the code. So that is one thing. If you're using a debugger, you don't have to worry about that because you're not putting extra print statements all through your code. Another tool that you definitely have to have is some kind of source control. It doesn't necessarily have to be Git, but Git is probably the most widely known and widely used amongst the software developers. You don't necessarily have to use GitHub. You don't have to use GitLab. There's tons of different repositories that you can host your code on. GitLab, Bitbucket, there's some other ones, GitHub, and then there's some other, you could even, if you really wanted to go ham, and you literally could create a folder on some remote system, created a bare Git repository, and push your code to there and use that as your remote Git repository if you really wanted to. I don't necessarily recommend that, but I've done it in the past and it does work, so you theoretically could. But definitely at the very least, you should have some way of managing your source control and your source code, and not having 20 different folders with a backup number and then, whatever iteration it is when you want to make a change to your code, but you don't want to risk bricking everything. Because I have in the past experienced issues where I'll have my code working and then I'll get too deep into making a change and it completely bricks the entire program, and then you're stuck in the conundrum of what do I do from here? If you have Git set up or some kind of source control, you can easily just roll everything back and you're good to go. But if you don't have source control in place, you are potentially out of luck and could possibly be just hitting Control Z for the next who knows how many minutes trying to get back to a working state. Or maybe you have some kind of other folder that you called source backup number 5 or something, and that's your most recent number. So you try to go to that, but then you realize that's not even up to date because you made that folder like 4 days ago when you had some other change that you were working on. So yeah, source control can really save your butt and save your bacon in some cases. So source control is definitely something that you want to have. Now, another tool that you want to have is some kind of testing environment. We've talked about this before. You don't want to be like me, as I talked about last week, and be the, works on my machine guy. You don't want to be him, because it doesn't feel good to be that guy. I didn't like being that guy, although I did find, as I mentioned in last week's episode, a workaround and was able to fix the problem. But you don't want to be that guy. So you want to have some type of testing environment. Now, whether this is an on-prem environment, whether you have a virtual machine just on your local machine, or you have a dedicated server somewhere, or you have a hypervisor with VMs running, or you have a cloud instance with a testing environment on there. Whatever the case is, you should have some kind of testing environment that you should test your code on. And I say this in specifically that it should be a different machine or a different virtual machine or some machine that is completely removed from your development machine. And the reason I say this is because I have run into the issue on multiple occasions where it not only does it work fine on my machine, but not on another machine. The reason it doesn't work on another machine is because either through installing dependencies or installing development tools or whatever the case may be, I have like libraries on my machine that aren't on, say, a stock machine. So specifically Windows is a prime culprit of this. So one of the tools that I like to use, I think it's MSys or something like that. It's basically kind of a way that you can install a command, the GNU compiler. But one of the issues with that is if you compile with that and then you try to move that code onto just a Windows machine that doesn't have that MSys thing installed, the executable generally won't work because there aren't the requisite libraries on that machine for the executable to run. So you want to make sure you have as close to a stock machine as you can to what you're building for, just in case you run into a situation just like that, where the executable is looking for some kind of other libraries or external dependencies that on your machine is built right into the path, so you don't have to worry about, but on another machine it's not configured that way, so you can figure those issues out before you full send it to prod. Some user pulls it down, it doesn't work, and you're like, it works on my machine. Don't want to be in that situation. So you want to have a test environment that's as close to a stock machine that you're planning to ship for as possible, so you can find these kinds of things that you otherwise wouldn't catch if you were just testing it on your local development machine. And then going off the testing environment, you want to have some kind of deployment environment or deployment strategy. And what I mean by this is if you're hosting some kind of web app, you're obviously going to want to have some kind of web server somewhere that you can then push your code changes to so your new website can be live. This could also be if you're writing some network-based service or some kind of server. You want some way to be able to deploy that, whether you're deploying that to a server, a dedicated server, or maybe you're deploying that as a Docker container for people to pull down the latest changes as a Docker container so they can run them. Whatever the case is, you should have some kind of deployment environment or strategy that is separate from your testing environment, because you don't want your testing environments and deployment environments mixed up, because That could potentially lead to the case where you push something to the testing environment, or what you think is the testing environment, to test it, but you actually pushed it to the deployment environment, and now things are all buggy. So you want to make sure that those are separate, and you're always pushing to the one that you believe that you should be pushing to. And then kind of on the topic of deploying, you should have some kind of build tools or build strategies or build paths set up for building and releasing your software. Now, this doesn't specifically have to be some kind of CI/CD pipeline. You don't necessarily have to go that route, but you should have at least some kind of set of routine or set of steps that you go through when you're doing some kind of build that will then end up as a released build. You want to make sure you have something like that in place, where even if you're not doing an automated thing where you push it to your Git repo and then it'll automatically run through a CI/CD pipeline to build, test, and deploy everything, you should at least have some kind of strategy in place to make sure that everything is good before you deploy it. But also, I want more specifically on the build tool side, I would recommend you have some kind of tool that you're familiar with to build your code yourself. So if you're using an IDE, this generally won't be an issue for you because most IDEs will automatically build all your code for you. So if you're using something like Visual Studio or Xcode or Eclipse, you can just kind of hit that like build button or run button and it'll build all the code for you. So you don't have to worry about it. But if you want to allow other people to be able to build your project that might not necessarily be using the same IDE or tools that you're using, you want them to still be able to build your project. So this is where some other kind of build solution like Make or Maven or CMake comes in, that you can essentially write a build instructions for your code. So if you've never used these before, I'll go with Make, since Make is the one I'm generally most familiar with. So basically how Make works is you can define rules and variables for the different source files and object files and different parts of your code. So what you can essentially do is you can just type Make, and what it'll do is it'll find all the dependencies that need to go into the executable and then go through the list of making sure that all the dependencies are met and then building the executable. So what this basically allows you to do is I can give you all my source files with this Make file, and all you have to do is type Make and it builds. You don't have to make sure that you have the same exact IDE as me with all the right configurations in place in order to build my code. All you have to do is make sure you have, Make installed and your folder structure, whatever, is the same as it is on mine, which theoretically, if I'm sending you the source code, all that would be in place anyway. So then you can just, type Make and it'll build it all for you. And CMake and Maven work pretty much the same way. But there are obviously some slight differences. So you want to make sure some way you have some kind of build path or build tools in place to build your code. Another thing that this might not necessarily be applicable to you is some kind of GUI editor. And the reason I say GUI editor is because if you've ever tried to hard code your own GUIs, it is a royal pain in the butt. So if you can have some kind of editor that you can essentially design the GUI in a visual sense, rather than having to code out all the coordinates and heights and widths and all that stuff, it's a lot easier. It's a lot less of a headache if you can use some kind of tool like that. But obviously, if you're just writing command line tools or writing servers or something that doesn't have any kind of user interface, you obviously don't necessarily need to worry about this. But it is something that could be good to have, specifically if you're working with user interfaces. Now, another tool is some kind of packet capturing software. Specifically, I like to use Wireshark, but if you're doing any kind of networking programming, some kind of packet capturing software like Wireshark is basically a must-have, because I've run into the issue where I feel like I should be sending the right data, but nothing's going through, or I should be receiving something, but I'm not getting anything. You can easily open up Wireshark or whatever packet capture software you're using and see exactly what's going on with the networking, to see where those packets are going. Are they going where you think they're going? Are they getting dropped somehow? Are they not? You can see all of that. You can see what's in the packets. If the data that you're getting in your program is not what's in the packet, you can check that. So any kind of networking programming, you want to have some kind of network analysis tool like Wireshark. Another tool that you want to have, this, I don't know specifically if there's a tool in mind that I'm thinking of, but some kind of logging capability. Whether you build that directly into your software or you have some other tool that can do logging for you, just some way to, log any kind of potential errors that are going on, or different states of your program, just to make sure you can get a visual of what's going on, just in case there is some undefined behavior. If you're logging things in your code and your program, you can go through those logs and see, what the issues could potentially be. And then another tool that is helpful is some kind of diagramming tool. So probably one of the more common ones is diagrams.net, or more formally known as draw.io, or some kind of Visio is the Microsoft version. Some kind of way that you can create visual diagrams for either if you're writing user documentation or interface design documents, or some kind of other programmatic documentation, or just in general if you want to storyboard something or kind of diagram out your code to kind of better visualize it. Some kind of diagramming tool can be very helpful for situations like that. And the last one that I have for you is the good old softball, which is a search engine. Because anyone that's done any kind of software development knows a lot of software development is going to your trusty search engine and searching up how do I do X in Y language, or why code no work. Obviously, you're going to be more specific than that. And once you get more into your software development career, you start to figure out how to search for things in your search engine of choice and browser of choice, to figure out what you should be searching for to get the good keywords that get you to the right Stack Overflow links. Which actually, maybe I should have put that here as another tool, Stack Overflow. Which I think we all, as software developers, have probably had that one experience where you searched for something, you found a link for Stack Overflow, you saw the first result you just decided to say, what the heck, you Control-C'd it, you Control-V'd it into your code, hit run, and it worked perfectly fine. I'm sure we've all had that experience at some point. If you haven't, either you're a lot smarter than pretty much every software developer that I know, or you're super early in your career and you just haven't gotten to that point yet. One of the two. If you're the former and you're just that smart and you've never had to use any kind of search engine before, and you just are an absolute mastermind of everything coding, and you don't even use any of the tools I mentioned, you just code everything in Notepad, with no kind of syntax highlighting or anything like that, and every time you build, it always builds perfectly with no errors, I would like to talk to you. So please hit me up at contact@darkassassinsinc.com. So I think that's probably going to do it for the tools. There's obviously other tools that you can have when it comes to being a software developer, but I think these are probably the main ones that you should be using, if not on a daily basis in your software development career, at least on a very regular basis. Because if maybe you don't necessarily need to use some kind of make file, for instance, to build your code because you're just writing personal projects for yourself, when you get into like an enterprise environment, you need to make sure that other people can build your code, and not everyone might be using the same IDE, for example. A good example for this is maybe you have Windows devs and Linux devs, and obviously Visual Studio is not going to work on Linux. So Visual Studio Code exists on Linux, but it's not the full fat IDE Visual Studio. So if your build path and build everything is set up for Visual Studio, you're not going to be able to port that to the Linux devs. So something to keep in mind. While you might not necessarily think you need some of these, they will definitely be important as you kind of get in further into your software development career. For me, for personal experience, the biggest one that I can say for sure is Git and source control, because that was something that I had never really used before in personal projects. I thought it was kind of pointless, as how ignorant I was back in the day. And I was definitely in the camp of, okay, I'm going to make some big changes here. Let me copy the source folder and paste it somewhere else as a backup. Just in case I mess up, I have a working copy. I was that guy at one point. So I'm speaking from experience here. And if you're one of those people that do that, I was like you back in the day. But source control and Git, once I actually started using it and learning it, it has made my life so much easier. Not to mention, it makes you more marketable as a software developer because you know how to use source control. And if you know how to use source control, it helps you to more easily integrate your development with other developers, because it's kind of hard to merge code bases if you're just constantly creating backup folders when just in case something goes wrong. So if you have two people's completely separate folder structures with no kind of source control, trying to merge those changes together can be an absolute nightmare. So Git can, basically do all that for you, which is super handy. Now, obviously, dealing with merge conflicts can kind of be a pain in the butt. But if you're theoretically, you should be working on different portions of the code. So ideally, you would never really run into merge conflicts, but those kinds of merge conflicts are things that you'd have to kind of sit down at some kind of, meeting or something and kind of go through, which are the right changes, that kind of thing. But definitely that is a tool that I think probably should be on the top of your list if you're not using to start using. But yeah, so those are the developer tools that I think the software developers should definitely have in their toolbox. And with that said, I think we are due to go over the trivia answer. So as a refresher, this week's trivia question is, what was the first computer virus to appear in the wild? So if you said the elk cloner, you are correct. And if you said it first appeared in 1982 on a Mac, you get 2 bonus points this week, which ironically, we talked about Macs, and Macs are known for not able to get viruses, which obviously is not true. But it's kind of ironic that, Macs have the stereotype of unable to get viruses, yet the first virus to appear in the wild was on a Mac. So that is, I think, kind of ironic. Good, sweet irony there. So a little bit about the Elk Cloner, if you've never heard of it before. Basically what it was a boot selector virus, which was pretty common back in the day before, partly before the internet was a thing, but also back in the day when, in order to boot your computer, you would have to insert the operating system's floppy drive. The floppy disk into the floppy drive. That's how you booted your OS. It would boot into memory, and then you could insert other disks and whatnot. So this was pretty common back in those days, this boot selector virus. And what was kind of funny, I guess, about the virus was it was created initially as a joke, which is kind of funny that the first virus to appear in the wild was made as a joke. So it was originally attached to a video game, and on the 50th time the game was started, the malware would basically be activated and would display a poem rather than the actual game. And if you're curious as to what the poem read, this is what it said. Elk Cloner, the program with a personality. It will get on all your disks. It will infiltrate your chips. It's a cloner. Yes, it's a cloner. It will stick to you like glue. It will modify RAM too. Send in the cloner. So that was the poem that would be displayed on this specific Elk Cloner malware. Now, this is one thing that is common even today amongst types of malware, where once they infect your system, some of them will just stay dormant for some period amount of time. And this is common today. It was evidently common in the very first one that was in the wild, at least. But another reason why malware will typically like to stay dormant is it'll try to figure out if you're a high value or a worthy target. So specifically in like corporate and enterprise areas, what malware will do is it'll infect itself onto some system and then kind of scan and search around like what kind of files and what kind of data are on the systems and potentially networked together systems to see if it's a good enough target to, say, deploy ransomware and to take over that system and that network, to see if it's a good high value target to potentially get money out of. So it's kind of interesting that that's a tactic used today in malware, and it was also used back in this original Elk Cloner. So the other thing, the way the Elk Cloner would work was it would infect disks by, when it was inserted, it would basically store itself into memory. And then when an uninfected disk was inserted into the floppy drive, the Elk Cloner would copy itself onto that uninfected disk, thus infecting it. And then that's how the virus would spread itself around. Now, one of the ways that it was able to detect if a disk was already infected was it would write a signature byte to the disk's directory, which would indicate that the disk had been infected. And this was beneficial for it because it wouldn't be constantly overwriting and writing itself to the disk if it already existed on there. So I did mention that there were viruses before the Elk Cloner, but those were generally regulated to, lab environments or testing environments. But one potential virus that I guess maybe could have been seen as before this was called the Creeper virus, which was also malware, but was more of an experiment than anything. It was like it wasn't like intentionally designed to be a kind of malware thing. It was more of an experimental type thing. But it was a self-replicating program that spread across the ARPANET, which was back before the mainstream internet. This was back in the 70s when this happened. But it was easily removed by another program called the Reaper program, which went around and cleaned it up. But that was another instance of a virus. But like I said, that was just for kind of experimental purposes, which is what a lot of the malware pre the Outcloner was just kind of regulated to contained environments, just for like testing and analysis reasons. So that was the trivia question and a little backstory behind some early days of malware. And if that's going to do it for this episode. So if you enjoyed this episode, I ask that you leave it a rating and review and subscribe to the Dark Assassins podcast if you haven't done so already. Also, be sure to share with a friend or family member, specifically any developers out there who you think would get some benefit from hearing about the development tools that they should have in their pocket, maybe in their toolbox. Maybe they have some, maybe they could add some more. And if you have any questions about this episode or have any comments or questions for future episodes, you can shoot me an email at contact@darkassassinsinc.com. Link is down in the show notes below for that. And as a reminder, next episode should be a pretty banging special one, so you're definitely going to want to make sure that you come back for next week's episode. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.